So look at here children. So again I have drawn neatly for nitrogen molecule. For one nitrogen atom it consists 7 electrons. For two nitrogen atom totally it consists how many electrons? 14 electrons will be present for two nitrogen atoms. So here bonding, antibonding, bonding, antibonding. This in this way the electronic configuration will take place. So for N2 molecule sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, next pi 2px2, pi 2py2, and next sigma 2pz2. So for this I am not going to write anti-bonding because so total 14 electrons, all the 14 electrons were arranged here. See 2 plus 2 4, 4 plus 2 6, 6 plus 2 8, 8 plus 2 10, 10 plus 2 12, 12 plus 2 14. So 14 electrons are we have distributed in these molecular orbitals, isn't it? So total 14 electrons are arranged here. So here a small trick what we have to follow is this nitrogen comes under rule 1. What I said, lithium, beryllium, boron, carbon, nitrogen follows rule 1, that is 2-1-2-1 rule. 2-1-2-1 rule, that means see molecular orbitals here 2-1-2-1 rule. Okay, and here in bonding first X, Y, Z, and in anti-bonding also X, Y, Z will take place. So we have to arrange the electrons in atomic orbitals as well as in molecular orbitals for nitrogen. In 1s orbital, and here for 1s again you can write simply KK. Okay, sigma 1s2, sigma star 1s2 we have written now. For this first orbital, that is K shell, we can write like this also, KK. KK means 2 electrons are completed. From here again you have to start sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2, sigma 2pz2. So you can write like this. So here 2 plus 2 4, 6, 8, 10, 11, 12, 13, 14 electrons are completed. So now we are going to arrange the electrons. So in K shell how many electrons are present in sigma 1s orbital? 2 electrons are present, isn't it? 2 electrons. So that means here in 1s 2 and here 1s 2. So total in one orbital 2 electrons, one orbital 2 electrons. In molecular orbitals how many electrons will present? So in sigma 1s, in sigma 1s 2 electrons are present, sigma star 1s 2 electrons are present. Next comes to 2s orbital. Okay, 2s orbital how many electrons are present? 2. So 1 2, here 1 2, and here also in bonding how many electrons are present? 2. In bonding or molecular orbital 2 electrons are present. In anti-bonding also 2 are present. Now comes to 2p orbital. So according to this electronic configuration, look at here 1s2, 2s2, 2p3, isn't it? So each one orbital contains one electron. 1 2 3, here also 1 2 3. So these atomic orbitals are combined to form molecular orbital. So here total 6 electrons are there. 1 2 3 4 5 6. Okay, total 6 electrons are present in 2px, pi 2px, pi 2py, sigma 2pz. So count how many electrons are present? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So here 14 electrons are present in molecular orbital and in atomic orbitals also. Here 2 2, how much? 4, 2 2 4 8, 8 plus 6 14. So balance, I think we have balanced everything. So now we have to calculate bond order. Bond order formula. What is the bond order formula, children? Nb minus Na by 2. So number of bonding electrons. How many electrons are present? Bonding 1 2 3 4 5 6 7 8 9 10. So 10 bonding electrons are present, and anti-bonding, that means star mark, 1 2 3 4. So 10 minus 4 by 2, that equal to 3. The bond order is 3. That means that is why the reason nitrogen forms triple bond with other nitrogen molecules. So nitrogen will be having triple bond. Why it is having triple bond? Because the bond order is 3. I think you understood how to draw this molecular orbital diagram for molecule, N2 molecule. So look at here children, another example, that is oxygen molecule. So for oxygen molecule, the electronic configuration of oxygen atom, it is atomic number is 8. Its electronic configuration is 1s2, 2s2, 2p4. So each oxygen atom has 8 electrons. So in a O2 molecule, there are 16 electrons, and the electronic configuration for O2 molecule is, see, KK. I have written directly, that is 1s2. Okay, 1s2, sigma 1s2, sigma star 1s2, that I have written as KK. And next is sigma 2s2, okay, sigma 2s2, sigma star 2s2, sigma 2pz2, because it is rule 2, I will tell again. And next 2px2, pi 2px2 and pi 2py2 and pi star 2px1 and pi star 2py1. So from this electronic configuration of the oxygen molecule, we are clear about that 10 electrons are present in bonding molecular orbital and 6 electrons are present in anti-bonding molecular orbital, isn't it? So what I said here, which rule we have to follow? We have to follow rule 2. What is rule 2, children? So rule 2 says that the arrangement of molecular orbitals should be what? 1, 2, 2, 1. And here bonding orbitals, first we have to write Z, next X, Y. And in anti-bonding orbital, here X, Y, Z. So this is the trick. Okay, for oxygen, for fluorine and for neon, this rule you have to follow. And for lithium, beryllium, boron, carbon and nitrogen, this rule we have to follow. If you know this, you can easily draw these atomic molecular orbitals with the help of these atomic orbitals, and here also. So now we are going to arrange the electrons. So in 1s, how many electrons are present, children? 2 electrons. So 1, 2, 1, 2. And here also 1, 2, bonding and in anti-bonding. In a 2s also it is completely filled. 1, 2, 3, 4. And in bonding, sigma 2s also 2, sigma star 2s also 2. And now comes to p orbital. In p orbital, how many electrons are present? 4. So arrange 1, 2, 3, 4. Here also 1, 2, 3, 4 electrons are present. So total how many? 4 plus 4, 8. 8 electrons we have to arrange here. And these are anti-bonding, no? I forgot to draw star. This is the star mark. So arrange in a 2pz, 2 electrons are present, and pi 2px, 2 electrons, and pi 2py, 2 electrons are present. Total 6 electrons are completed, and the remaining one will be present in here and here. Yes, 2px and 2py orbital, it is present. So now count how many bonding electrons are present. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So bond order for oxygen is Nb minus Na by 2. So how many bonded electrons are present? 10 minus, now anti-bonding, 1, 2, 3, 4, 5, 6. So 10 minus 6 by 2. So 10 minus 6 how much? 4. 4 by 2, that is 2. So bond order is 2, that means it forms double bond. So oxygen forms double bond with other oxygen atom. So this is how you have to represent the molecular orbital diagrams for nitrogen and oxygen. With the help of this small trick, you can write for other molecules also. Understood, children? And the last subtopic of this chapter is hydrogen bonding. So by name itself you can understand hydrogen bonding means hydrogen forms some bond with other atoms. So here whenever we talk about electronegative elements like nitrogen, oxygen, fluorine, So these highly electronegative elements, when combined with hydrogen atom, what they form? They form covalent bond. They form covalent bond. That means sharing of electron will takes place. But here the electrons of the covalent bond are shifted more towards the electronegative atom because they are having more number of electrons in their outermost shell when compared to the hydrogen atom. So whenever hydrogen forms bond with highly electronegative elements like fluorine, what happens? More pull towards this, okay, the covalent bond shift more towards this electronegative atom. So when it pulls this, when it gets this electronegativity, then the fluorine atom partially gets or partly or it gets partial negative charge, and hydrogen atom will get partial positive charge. So here hydrogen bond acts as a bridge between these two atoms, which holds one atom by the covalent bond and other atom by the hydrogen bond. Understood, children? So here again hydrogen and fluorine, this is get partial negative charge, this one is partial positive charge. So these dotted lines are there, this is called hydrogen bond. Hydrogen bond. Here hydrogen bond acts as a bridge. How it is acting? It is acting as a bridge between the two atoms, which holds one atom by the covalent bond, one atom by the covalent bond, and other atom by this hydrogen atom. Sorry, hydrogen bond. So here look at here. So this is hydrogen bond and this is covalent bond. Isn't it? This is covalent bond, again this is hydrogen bond. So this solid line is called covalent bond. This is covalent bond. This is hydrogen bond. That means hydrogen bond can be defined as attractive force which binds the hydrogen atom of one molecule with the electronegative atom of the another molecule. So understood, children? So whenever hydrogen combines with highly electronegative elements like nitrogen, oxygen, fluorine, what happens? The electrons of the covalent bond are shifted towards the highly electronegative or more electronegative atom. So when they shift towards this, they get partially negative charge and this hydrogen get partially positive charge. So this holds an atom together. So due to this imbalance of this charges, what happened? The atoms are held together with a bond. So here the dotted bonds are called hydrogen bond and this solid bond is called covalent bond. Now we are going to see the causes of formation of hydrogen bond. So how a hydrogen bond has been formed or caused? So already here I explained, when hydrogen is bonded to strongly electronegative element X, the electron pair shared between the two atoms moves far away from the hydrogen atom. Okay, move far away from the hydrogen atom. So as a result, hydrogen atom becomes highly electropositive with respect to the other element. So there is a displacement of electrons towards this highly electronegative element, we can see. So that means, that is why the reason this will get a negative charge and this will get positive charge. So by getting this oppositely charged, what happens? So this results in the formation of a polar molecule having electrostatic force of attraction. Okay, electrostatic force of attraction. So look at here hydrogen which is bonded with highly electronegative element. So the shift of electrons towards this highly electronegative elements causes to get partially negative charge. So due to that, this one will get partially positive charge, isn't it? And again it combines with another hydrogen atom. So same. So this is hydrogen bond, this is covalent bond. So this results in the formation of polar molecule. One will be positive, another one will be negative, like that. So one will be positive, another one will be negative. So the magnitude of hydrogen bonding depends on the physical state of the compound. Okay, the magnitude of the hydrogen bonding depends on the physical state of the compound, and it is maximum in solid state and minimum in its gaseous state. So the hydrogen bonds have strong influence on the structure and the properties of the compounds. So what did you understand here? Whenever hydrogen atom combines with highly electronegative element, hydrogen atom will get partial positive charge and the other atom will get partial negative charge. That is the main thing. And how hydrogen bond is represented with dotted lines. Understood, children? Next, types of hydrogen bonds. Types of hydrogen bonds. First one is intermolecular hydrogen bonding. Intermolecular hydrogen bond. Okay, intermolecular hydrogen bond. So it is the bond, it is a bond formed between two different molecules of the same or different compounds. For example, hydrogen bond in case of HF. Okay, HF molecule or alcohol, or in water molecule also HF or H2O. So intermolecular hydrogen bonding, that means it is formed between two different molecules. This is one type of, this is one type. So this is called between the two. And next one is intramolecular hydrogen bond. Intra means within, inter means between, intra means within. So intramolecular hydrogen bond, it is formed when hydrogen atom is in between the two highly electronegative atoms present within the same molecule. For example, so look at here, one diagram I am going to draw. This is oxygen and here also oxygen. Between hydrogen is present. This is dotted line. So this is called orthonitrophenol. So here hydrogen is present between two highly electronegative atoms. So intramolecular hydrogen atom is formed when hydrogen atom is present between the two highly electronegative atoms. Example is orthonitrophenol. So these are the two types of hydrogen bonds, and this is about hydrogen bonding. So by this we have completed our third chapter, and states of matter fourth chapter we are going to start in the next class. Thank you, children.